All right, let's dive right into this explainer and trace the totally fascinating journey of how a raw chunk of steel is engineered into a precision instrument of forensic evidence. When we think of forensic ballistics, our minds usually go straight to the yellow crime scene tape, right? Or maybe the highly calibrated microscopes back at the lab. But the real story of a bullet's unique signature, well, that actually begins long before any of that happens. It starts right on the factory floor, right in the middle of all the noise and heat of heavy manufacturing. So think about this. Here's the core mystery we're going to unravel today. How does a solid block of steel become a unique forensic fingerprint? At first glance, it feels, I don't know, completely counterintuitive, right? I mean, mass manufacturing is literally designed to make everything completely identical. But we're going to explore this crazy intersection of heavy machinery and microscopic precision to uncover exactly how this transformation happens. And spoiler alert, we'll see why absolute perfection in machining is actually a physical impossibility.
Here's our quick factory blueprint for this explainer. First, the raw steel blank. Second, gun drilling and reaming. Third, the art of rifling. Fourth, lapping, the final polish. And finally, we'll wrap up with the forensic connection.
Okay, let's kick things off. Section 1, the raw steel blank, starting the factory tour.
As you might guess, every incredible manufacturing journey has to start with the raw materials. In this case, it begins with choosing really high-quality solid metal. We start with 3 heavy-duty stages of macro-level preparation. All this happens way before the intricate interior engineering even begins. You select a superior piece of solid steel, next you cut that solid metal down to a manageable size, and finally, you begin the broad strokes of machining it. At this stage, honestly, you're essentially just looking at a heavy, pretty unremarkable tube of steel. The whole forensic identity we're looking for, it hasn't even been born yet.
Moving right along, Section 2, gun drilling and reaming, carving the path. This is where we enter the core machining phase. We're transitioning from the outside of the barrel to the inside with a really critical deep drill operation. Now, gun drilling is exactly what it sounds like, but the engineering required to do it correctly is intense. It's a deep hole drilling process that uses a very long, thin cutting tool to produce holes at incredibly high depth to diameter ratios. It requires just immense stiffness to resist deformation. Why? Because of the massive heat generated while punching a perfectly straight hole through the entire length of the barrel. You are forcing metal against metal at incredibly high speeds, so controlling that heat and stress, well, that's the first great hurdle of barrel making. And this initial super aggressive drilling operation gives us a foundational measurement. The diameter of this newly drilled hole depends entirely on the downstream rifling equipment that's going to be used later, which sets the stage for what we officially call the bore diameter. So the bore diameter is simply the minor diameter of the finished rifled barrel. It is quite literally the empty space we've just violently carved right out of that solid steel block. So the crucial point to grasp here is the sheer contrast between drilling and reaming. Drilling violently punches the raw path, right? While reaming uses a longer cutting tool with side edges to perfect the alignment. Think of it as a two-step process, brute force followed immediately by precision control. Drilling creates the initial deep, straight hole. Reaming, on the other hand, is the finesse operation. It steps in to refine that hole, specifically finishing the bore down to highly specific dimensions, like, say, exactly 0.300 inches. This sets up the exact tolerances required before any further modifications can even happen. Actually, scratch that. Let's zoom in on that finesse for a second. Reaming acts to smooth out the violent aftermath of the initial drilling, leaving a refined and highly calculated surface behind. To ensure proper alignment and straightness, the reamer tool is much longer compared to its diameter. And because the reamer is required to remove very little metal, we are talking microscopic shavings here, its working edges are finely honed. The overarching goal is simply to reduce the extreme roughness left behind the drill. But, and here is our very first major forensic clue, guys, quote, the surface of the barrel hole is smooth, yet reaming can leave markings that may ultimately be passed to a fired bullet. This right here is the exact moment where the magic happens for forensic ballistics. Because despite all the smoothing and the finely honed edges of the reamer tool, that metal-on-metal contact still leaves behind microscopic scratches. These tiny imperfections are left all along the interior of the barrel. They're invisible to the naked eye, for sure, but they are absolutely permanent. Which naturally builds into our next crucial stage. Section 3, the art of rifling, imparting the spin. Now, this step is entirely dictated by the precise blueprints of modern handguns and rifles. Rifling is the absolute key to accuracy. It's the physical cutting of spiral grooves into the metal that literally force the bullet to spin tightly as it exits the barrel. This process is applied only after the initial hole is made. It creates what we call lands, which are the raised sections of the original bore, and cut grooves. These lands and grooves form a continuous spiral all the way down the length of the barrel. When a firearm is discharged, the bullet gets forced through this tight space. The spiral lands grip the softer metal of the bullet, causing it to spin. That spin gives the bullet aerodynamic stability, vastly improving accuracy. But mechanically, it means the bullet is being dragged under immense pressure directly across all those microscopic manufacturing scratches we just discovered.
All right, moving to section 4, lapping, the final polish, smoothing the grooves.
So the energetic, kinetic cutting of the factory floor is pretty much finished now. The whole process slows way down for a meticulous, final polishing phase. Lapping involves drawing a closely fitting lead piece back and forth on a rod, carrying with it a polishing compound. This lapping operation carefully polishes both the newly formed lands and the groove areas inside the barrel. Its main purpose is sweeping away the larger impactions that resulted from the aggressive cutting or forming tools used earlier. It's a finishing touch. And pay really close attention to this phrasing. It removes the larger impactions. It absolutely does not erase the microscopic structural marks.
And finally, we arrive at the culmination of our tour, section 5, the forensic connection, the blueprint versus reality.
Okay, so here is the grand takeaway of our entire exploration today. While firearms are manufactured based on identical blueprints that specify configurations for perfect mass production, the extreme physical reality of machining metal guarantees that no two barrels will ever carry the exact same microscopic signature. Every single time a drill bites into steel, every time a reamer smooths a bore, and every time a rifling machine cuts a groove, the metal chips and shears in completely tiny, unpredictable ways. Furthermore, those cutting tools wear down fractionally with every single barrel they process. The result? The blueprint might be identical, but the machined reality is totally one of a kind. These unique microscopic markings are then violently transferred to the bullet when it's fired, acting as a perfect ballistic fingerprint.
Makes you look at things a little differently, doesn't it? Just knowing that the history of an object's creation is forever carved into its surface, waiting to be read. I mean, if every single machine stroke, every drill, and every polish leaves a completely distinct trace, what hitting forensic signatures do the mass-manufactured objects all around you carry in your everyday life? Think about that for a second. I hope this explainer has sparked a new curiosity about the intricate and invisible world of manufacturing. Keep exploring, stay curious, and we'll see you in our next explainer.